changed, and we can talk about what's changed in the last few years as we get into the slides. So this is a little milder version of the version I used to give, hopefully because I'm becoming more humble instead of more arrogant. But if you ask my wife, she might have a different version of that. So this is very high level. It's more business oriented, and it's very not technical. And I guess the main purpose of the talk is to kind of stimulate some thought about where the profession's heading and how we need to change if we're gonna stay relevant and be successful, and kind of what role GIS plays in that. I'll look at some examples I have here. I've been very fortunate to have been pretty successful with GIS. I know a lot of surveyors try it and aren't as successful. So I've been fortunate, and I hope to do more of that kind of work. So we'll go ahead and get in here. Please, if you guys have questions, stop, or if you have a disagreement with something I've said, stop and we'll talk about it. We're actually going to move, this is kind of the condensed version. This is supposed to be 2 to 4 hours, and we're doing it in an hour. So this is a little job we just did. It's a pro bono project. Something like, I think there's 25 Spanish missions along the El Camino Real, California. Anybody ever been to one of the Spanish missions? Yeah, so almost everybody. So there's a little mission outside of Paso Robles in San Miguel, Mission San Miguel. It's a beautiful, beautiful adobe building. If you're ever passing through Paso Robles, it's only about 10 miles north or 15 miles north on the highway. A really beautiful building. So there's an organization called SciArc. Maybe some of you guys have heard of that. SciArc goes around the world and does terrestrial laser scanning of historical sites for historical preservation. And so we teamed up with them and a professor and some students from University of San Francisco to scan this mission. We got another trip to make, but we didn't quite finish, but we got the bulk of it. So anyways, those are a couple of the students there. We're out in the front plaza. You can kind of see the adobe columns. This is a kind of a wing wall that goes into the main building. It's about 3 stories tall. Anyways, it was a fun project, and the students learned a lot. Somebody bought those guys. There's the architecture department at University of San Francisco. Somebody bought them a Leica C10 scanner, and like they're architecture students, right? Like they had no clue how to use this scanner. So, anyways, by the end of the weekend, they were like setting that thing up on the tripod. They were shooting control. Like it was a blast. We enjoyed being able to teach them. So, one of the reasons that's on this slide is technology, of course, is driving change. And my wife and I were talking about that. My wife's a preschool teacher. And I was making a comment about how much technology has changed the way we survey. She says, well, you know, technology's changed in my field too. And that's probably true. But I would suspect technology has changed surveying a little more than it's changed teaching in the last 25 years. You know, you do some online stuff now with teaching, but I would imagine if you went back 25 or 30 years, I'm not old enough to do that. Some of you guys might be. You probably wouldn't recognize surveying today. And I can just, in my lifetime, like I remember, I'm 35, so I'm not that old, but like even in the last, let's say 15 years, we forget how much things have changed. So, anybody do early static surveys? Okay, and do you remember what time you had to go out to do your observations? Like I remember being out like 4 in the morning, because that's when you had 5 satellites in the sky, right? Yeah. You know, so I remember going to school and doing that. I remember we had a class on GPS that my professor taught. And like, he had no clue what he was teaching us. Like it was that new. Like he had a class, but we didn't know what we were doing, right? And so even something as simple as GPS, I mean, think about just how GPS has fundamentally changed the way we do work in the last 15 years, right? And another thing, they didn't have robotic total stations when I got out of college. I remember we got the very first Leica robotic total station that they made, and I happened to be low enough on the totem that I was the guy that got to figure out how that thing worked. And that thing was a disaster the first 3 months. I mean, there was all kinds of software glitches, and the thing would follow taillights going down the road. And I had a chance on this job. I don't get out very much, but I went out and ran a Trimble S7. Man, like we're talking about the difference between a moped and a Cadillac from that first robot. Like that thing was super sweet. I'm like, no wonder you guys are getting so much done, right? Big, huge difference. Reflectorless EDM was something else they didn't have when I started. LiDAR wasn't a big thing. Terrestrial laser scanning. Now they got LiDAR that sees underwater, right? So they'll actually do coastal surveys, and just so you can get penetration underwater. So major revolutions. And it's really changing the way we work. And so hopefully that, I think that'll continue to happen. And at the same time we have that, we have this kind of flip side. And I was talking to one of the surveyors earlier about this. We have all that technological change, and then there's still counties where I have to physically drive myself to the county surveyor's office to look at the map index, right? So it's like we kind of live in this weird world. It's a really weird world we live in. But these technological changes are important. And so let me ask you about, you guys, I listen to NPR, there's a show called Planet Money. It's a little economics podcast. It's really good, it's not dry at all, so if you're interested in business, check it out, Planet Money. But they did a show about the taxi king of New York City. And so if you want to run a taxi in New York City, do you know what you have to have? You have to have something from the city. Do you know what it is?
Medallion.
A medallion, yeah, a taxi medallion. Yeah, so do you know what a taxi medallion was worth about 4 years ago in New York City? Anybody want to guess?
$1 million.
$1 million for a taxi medallion, yeah. And this guy had like 40 or 50 taxi medallions, so he was a multi-millionaire. And what do you think has happened to that guy in the last 4 years? Anybody want to guess? Go ahead, Paul.
Uber.
Yeah, that guy's got decimated by Uber. In fact, he just filed for bankruptcy, and his wife is leaving him. Apparently, she's not into a man that doesn't have $50 million, I guess. So he's not doing good. I just heard this on the radio the other day. Yeah, now, so when you think about him, I think there's some lesson there for surveyors, and he's probably more like us than you realize. So what are some of the lessons from that guy, from the taxi king of New York City, do you think, for land surveyors? Paul?
Well, if you compare the taxi medallion to a surveyor's license, right now, it's worth a lot of money.
Yeah.
But we've got the GIS people creeping up on us, and other, you can just go online and download orthophotos. So those kind of free, cheap, and easy services are going to start encroaching, have already started encroaching on what was once our exclusive domain.
Yeah. So it's interesting, Paul he hit the nail on the head there. There's some interesting parallels there, and we'll tie this into GIS in a minute. Essentially what the taxi king in New York City had was an artificial monopoly because of the regulation that the city had in place. Now, that sucked if you were in New York City and you wanted a taxi, but what was the government's justification for that regime? They had what they think was a good reason. Does anybody know what it was? Why did they regulate? Why did you have to have a medallion to run a taxi in the first place? Does anybody know the reason? It's the same reason our public safe, what do they call it? Health and safety? Public welfare? Yeah, do you know why they license surveyors? What's the government justification for that?
Consumer protection.
Yeah, public health and safety. Yeah, same reason, right? So the parallels are almost a little bit scary, aren't they? Yeah. Now I'm not here to tell you that we shouldn't license surveyors. We'll save that argument for another time. But listen, here's the thing. You still got to have a taxi medallion in New York City to run a taxi. That never changed. But when you have a technology that comes in like that so drastically improves an existing market, is there really anything the politicians can do in the long run to stop it? No, in the long run there isn't. And so that's what happened there. And so let's talk about an example, and then I got another slide where we can evaluate some technology. So think about construction staking for a minute. Raise your hand if you've ever made good money rough grade construction staking. I know I have. I've made some good money doing that, yeah. So most of us have done that. If you're a rough grade construction staker, and that's all you do for a living, how's your future look like right now? Not good. Now I can't remember the last time I set a rough grade construction stake. Now I'm not going to say there aren't guys still doing that, but why do we not set rough grade construction stakes anymore? Machine control. And it's not just machine control. For whatever reason, I live in Stockton, I commute to Modesto. Every freeway within 200 miles of my house right now, they're doing road construction on. And do you know what I see every day when I drive by that freeway? What do I see on those job sites? Every day. And it's not machine control, it's something else. Every day, without fail, what do I see on that job site? Somebody with what? A GPS rover. Every day I see somebody with a GPS rover. Now, are those guys surveyors? The guys I'm seeing? They are not surveyors. Who are they?
Grade setters.
They're grade setters. Now listen, I love the guys in the room behind the wall here, right? I really love them. They hesitate to sell that equipment to a grade setter? Do they think twice about it? They don't think twice about it, right? So this is this is something that we got to give a lot of thought to. Now listen, I'll tell you right now, if I was the project owner, would I want my grade setter running around with a tool that he isn't qualified to use? But a lot of project owners don't care. And we could tell all kinds of stories about how things get screwed up on a job site when you got a contractor running around with GPS, but it's a problem and it happens. So we need to think about that. So I've got a slide here that will hopefully help us a little bit. So lots of new technology. I think we're going to continue to see this. So if you're in business like me in the private sector, you have to evaluate what these different technologies are going to do to your business model. So I've got some different categories here. Some different things that technology does, and sometimes it can be more than one. So let's start at the top. Sometimes the technology just makes existing surveying services more efficient. So you might put the EDM in that category, right? The electronic distance meter, or maybe robotic total station, or like let's say a reflectorless EDM. So did the reflectorless EDM make certain types of surveying easier and more efficient? Yes, it did. Did you still have to have a fairly high level of knowledge to run that piece of equipment? Yeah, you did. There's some training that went into there. So, made an existing surveying service more efficient. Here's the business mistake surveyors make. What's the first thing we do when we get a piece of equipment that makes our work more efficient? What's the first thing we do to our rate schedule?
We don't change it.
Or we lower it, right? Or we immediately pass 100% of that value on to the client, right? Even though we're paying for that new equipment. So that's a problem, but at least that's not putting us out of business. We're just eating top ramen, right? On the top one. Okay, let's go to the second one. You can have a technology that erodes an existing market. So we talked about some examples of that, machine control, right? Or contractors that are using GPS. I mean, that's work that's gone, it's not coming back. It's just not coming back. Okay, then we have one that creates a new market for surveyors and for others. So can anybody think of a technology that's done that in the last 10 years? Created a new market. In other words, it's work we weren't doing before, typically. Scanning, yeah. Like my company got hired, we scanned a 1,600 foot long, 70 foot tall concrete dam in Yosemite. It was built in like 1916. And it's in northern Yosemite. It's about to fall down, that's why we're scanning it, right? Would I have got that work 10 years ago? No, I wouldn't have got that. That's a new market that's been created, right? But listen, are we the only ones running around with scanners? No, we're not the only ones. So, that's a 50-50 on that one, right? We got some new work, but we got some other people using the technology. Okay, and then down here at the bottom we have some technology. Sometimes just creates a new market for surveyors. So it's sophisticated enough, or the regulatory regime is set up to where you still have to be a surveyor to do that. So you could use, as a narrow example, RTK GPS or robotic total stations. Those are great tools. It's fabulous to use those for a boundary survey. Can you do a boundary survey with those tools if you're not licensed? No. So, that's an example of some technology that's helped us because of the regulatory framework. Most of that benefit has gone to us. So I find it helpful when I'm thinking about technology and what I do, what's the future of my business over the next 10 years, to think about what those different changes are. And of course, this is the one that becomes really dangerous. Those technologies that erode an existing surveying market. Okay, let me see what's up next. Now, I used to be really, really worried about this. I used to think that maybe surveyors were going to go away, that eventually the technology would be good enough that we would just get automated out of existence. Like, I'm really, really worried about that. I don't worry about that as much anymore, as much as I used to. And the reason why is because over the last 5 years, I've come to appreciate how hard it is to do what we do and do it well. And if you've ever owned a surveying business, you understand that. Anybody can buy a piece of equipment. And I'll use scanning as an example. You got $100,000, you can buy a scanner, a good scanner, right? Does that mean you know how to use it? Listen, buying that piece of equipment and using it well are two different things, right? And here's what a lot of surveyors did, and I knew some of them. Surveyor run out and buy a scanner and they start producing point clouds. How many of your clients want a point cloud? None. None of your clients want a point cloud. They do not care about that point cloud, right? So I'm a little less worried than I used to be. I still think there's going to be a role for highly skilled surveyors when they evaluate and select this technology. But there are some things that I think are going away. So rough grade construction staking we talked about, I think that's going away if it's not gone already. You know, if you're the kind of surveyor that just provides raw data, you know, like if you go out and you do a topo and you do a survey and you send your client a point file, like I think you're in trouble. I think where surveyors need to move up the value chain, and I'm going to show an example of that, and I think GIS is a way to do it. So, you know, if you're somebody that scans stuff and you just give people point clouds, you're going to be in a low profit margin business really quick, because it doesn't take that much skill to just give people a point cloud, right? You got to be a surveyor to give somebody a point cloud? No, you can buy a little Faro scanner for $25,000, set that thing up, no survey control, right? You can do point clouds all day long. And I argue about what the quality of your data is, but some clients don't care. All right. So here's one of the things that makes me worry less, and this is something that I just thought about maybe the last 6 to 12 months. It's been kicking around in my brain now, so I'm curious what you guys think about it. Here's what I think is going on. My boss and I were talking about this a couple days ago on a road trip. So the technology, so you're going to go out and do a topo. Does it seem easier today or harder than 30 years ago? What do you think? On its face, what does it seem like? It seems easier, right? You know, if you go back 100 years ago, you wanted to do a topo, right? You brought 5 guys, right? You had the lead chainman, the rear chainman, the guy with the machete, the instrument man, the party chief, the cook, the guy that was, like it was a major project to get anything done, right? Okay, so it appears easier than it used to be, right? I'll give you an example. I took my nephew who was going to school to be an engineering student, never surveyed before. I took him down to that job where we scanned the mission. And how long do you think it took me to teach him how to run that S7 robotic total station? Like, not an expert, but I'm talking about set the thing up and take some shots. How long do you think it took me to get him? An hour maybe, right? Like, and I had to be around, but I could get him set up, make sure he checked his backside okay, right? And then I could leave and go do something else. He'd work for 45 minutes. Shooting targets, shooting corners of windows, different things like that, shooting column lines, right? So it appears to be very easy, right? Which is, for me as an employer, that's a plus. That's a positive. But here's what I think is going on. What we're really doing, now listen, the technology that's in the box, this applies to GPS and laser scanning and other things we do, is that getting simpler or more complicated? The technology inside the box.
Way more complicated.
Way more, like on orders of magnitude complicated, right? Like listen, I like GPS. I'm a techie guy. I've done a lot of reading on GPS. Like I can write code. I can write a little bit of software code, right? Like I probably know more about GPS than your average surveyor. I'm not an expert, right? Do I have any clue about how that really works inside? Probably not, right? I'm more educated than probably your average GPS user, right? So what we're really doing is we're hiding this actual complexity behind an easier user interface, right? Now, when we consider the implications of that for society, what's the problem with that model? What's the problem with that? There's a danger there. What is it? We keep hiding more and more complexity behind this user interface. What's the danger in that?
The manufacturers say any monkey can run it.
Yeah, and you can take it out of the box and push the buttons, right? Where is that going to get us into trouble, though?
Because they say it's super accurate and
Like,
powerful.
disaster waiting to happen, right? Yeah, I'll give you a perfect example. I bought a drone a couple years ago. $2,500 I paid for a nice drone, mapping grade drone. Now they call it an unmanned aerial vehicle, right? What does that make you think? You pull it out of the box and you hit the start button, right? And you wait for it to come back. You got your data, right? Okay. Has anybody flown a drone? Anybody in here flown a drone? Raise your hand if you think that's what it's really like to fly a drone. Let me tell you something. You have to have a skilled pilot at the control of that drone. And if you don't, what's going to happen? You're going to hurt somebody. Now listen, I haven't read yet about a surveyor that's killed anybody with a drone, but it is going to happen. Somebody is going to kill somebody with a drone. They're going to put it through the windshield of a car or into a building. Or listen, you drop a 15-pound drone on top of somebody from 300 feet in the air, and you're going to cause some damage, right? So this is a problem that we have to deal with. And we're going to close this with, well, why, why is like, have I depressed everybody yet? I'm depressed, right? Okay, look, it gets better, so hang on. All right, so let's talk about this other trend, spatial data trend. Now here's what happens is that technology gets easier, and we move to this world of bulk data collection. What happens to the cost of spatial data? What happens to that cost? It goes way down, right? Like, used to be when you wanted a topo, you sent out the 5-man crew with the mule, right? Like, listen, if you want, we have the drought. Here's an example. We have the drought in California. We got all these reservoirs that are like historic low water levels. And my phone was ringing off the hook with utility companies and other people that manage these reservoirs. And you know what they all wanted to do? They wanted to fly those reservoirs with LiDAR, right? So that they could calculate volumes and do things like that. And listen, I'm not the most expensive shop in town. I'm not the cheapest guy, but you think I could compete? You think I could compete on those LiDAR contracts? I could compete, right? We've got a similar thing that goes on. The city of Modesto came out with an RFP for orthophotos, like whatever 5-year orthophoto update, and they didn't use QBS. And you think a California land surveyor got that contract to do those orthophotos? What do you think? Where do you think the firm is located that's doing those orthophotos?
Kansas?
China. It's China. Yeah. It's not California. See, so ultimately what's happening is as technology gets better and better, it gets easier to use, is the cost of the data is going down. But there's a flip side to that coin that people don't think about, not all of them, and a lot of project owners don't think about that. As you acquire more and more of this data, more cheaply, and you hide that complexity behind that user interface layer, what cost goes up? The cost to maintain that data and extract value from it goes up. And let me give you an example. How many guys in here are running a scanner? Using a scanner in your surveying operation? Okay, one or two couple guys? All right, so I've been at a couple firms that use scanners. So listen, you go out and you do a topo with a total station, how big is that data file that comes back? That point file? 10 kilobytes, 20 kilobytes, right? Okay, you go out and you do scans, and you do high resolution scans with color photos, right? Like we did a job, we just did a job, I think the data was 25 gigabytes for 40 scans, okay? Now here's the thing you don't think about when you go buy the scanner. And listen, the sales guy doesn't tell you this. You start kicking around 45 gigabytes of scanner data on your network, your office network? Do you do that? No, the answer is no. You don't work off a network drive with that data. Like, it lives on your hard drive, right? Now, we don't think about that, but think about all the complications that come with that. Once that data is on somebody's local drive, how do I back it up? How do I have multiple people working with that data at the same time, right? How do I keep track of edits? How do I get that data to the client? There's just all kinds of complications that come because now I've got this massive amount of data, right? And that's just one example, okay? There's all kinds of public agencies right now and other organizations, utility companies, they are drowning in data, right? And so what do you do with that, right? So there's a cost, there's a flip side, there's a cost, and GIS can help solve some of that problem. All right, let's see what I got next. I'm forgetting my slides. All right, so we'll talk about the value chain for a little bit, and then we'll try and connect this to GIS finally. So here's one thing about this talk that I haven't changed my opinion on. So this has stayed the same the last 5 years. If you're working in the data production, the production of raw data, and that's your business model, if you're giving people point clouds or your job is to produce ortho photos, what's going to happen to your profit margins over the next 10 years? You're going to get squeezed tighter and tighter. It's going to get harder and harder and harder to make it in that business. So listen, if you want to stay in business as a land surveyor, what do you have to do? You got to move up the value chain, add value, right? So I tried to do a diagram here with an example. Let's take scanning for an example. Listen, there's all kinds of guys running around in my part of Central California with a little far-out scanner, and they'll go in and scan your building, your brand new building. They'll scan it. Can I compete with those guys? Listen, they're not licensed. They don't cover E&O. They don't carry E&O insurance. They're working out of their garage. They don't set survey control. Like, can I compete with those guys practically from a business perspective? No. And listen, there's a lot of contractors now, let me tell you what happens with scanning. There's a lot of project owners now that tell their contractor that the contractor has to do laser scanning as part of the construction process. Now here's the problem with that model, and I want to slap these project owners because they just don't get it. But does the contractor care at all about the quality of that laser scanning product? What does he want? He's only worried about two things when it comes to that service. What is it? Cost and speed. Yeah, thank you. That's all he's worried about, right? Now listen, I can compete on speed, but I can't compete on cost. Right? My boss has a saying he likes to say, high quality, speed, low cost, choose any two, right? But you can't have three. Okay? So listen, don't buy a scanner if you want to make money selling point clouds. If you're a surveyor, you aren't going to make money. So let's move up one step in the value chain, all right? Now you've got a guy, a surveyor, right? You go out and you set good control with your total station. You can put all those scans together. So we did that at that mission I scanned. And our typical fit scan to control on our average scan was 3/100 of a foot. Now that means you can measure any feature on that building and basically be within a half a tenth, let's say. Okay? I think our worst fit when we got inside the building, we had some poor geometry in the control, was 15/100, but that's pretty impressive. Now we've got that building scanned, it's registered on good control, the control's on state plane coordinates, so there's some added value there, right? You're not going to get that from the guy with the faro. Let me give you a perfect example. I had a call from a contractor who wanted us to do some scanning. They were remodeling two different parts of a hospital. They were doing the 3rd floor and the 5th floor. Now, what's the problem with the guy that's running around with the faro?
He gets stuck on the 4th floor.
Yeah. Listen, can he fit those two floors together? No, see, because if he can't scan to scan, if he can't bridge it with scans, he can't get it to fit together. Listen, is a surveyor going to have any problem getting those two floors to fit together? I had that come up on another job, another hospital. They were doing a major remodel, one wing of the hospital, right? And so they didn't want to pay us. We told them, look, just scan the whole hospital while we're in there, right? Save yourself a little money. We don't have the money for that. There's no way we're going to get the budget to scan that whole hospital. They're like, why should we hire you? I was like, here's why you're going to hire me. Because I'm going to scan the radiology wing of the hospital. That's what they were remodeling. I said, 2 years from now, when you go to remodel the ER, right, you're going to hire me to go scan that. And guess what? It's going to fit together, right? You hire the guy with the faro, he's going to be 1/3 of my cost. But in the long run, see, you go back to that slide with the data management cost. In the long run, are they saving money? I had a call from a guy at Lawrence Livermore Labs. Called me up because he knows we do scanning work. And he said, we hired some company from Virginia to come out here last year, the year before. They scanned a bunch of stuff. We don't even know what to do with their data. Right? Like, okay, you got a good price though, didn't you? Like, they got a good price on that work. You see? So that's the problem. So, okay, so that's one step. Now, let's move up another step in the value chain. So now we've got a good registered point cloud, right? But most clients, is that what they want? A good registered point cloud? No. So what's the next step up in the value chain? Why is the client having you scan something to begin with? There's a reason, all kinds of different reasons, right? Why were we scanning the dam? What do they want to know?
Deformation.
Is the dam falling down or not, right? Now listen, can you answer that question from a point cloud? Directly, can you look at the point cloud and say, yeah, the dam's falling down? No, there's some other product you got to get to, right? Okay, and in that project, what the key is going to be is, like, guess what? They'll answer some of that question with the first survey, but when are they really going to answer that question? Next year when we go out and scan the whole thing again, right? And then they're going to have us overlay cross sections and profiles, and they can see how that dam is moving. So see, the next step up the value chain is some type of product. Maybe it's a 2D plan view, maybe it's a set of cross sections, maybe it's a 3D model, right? Something that people can work with. Because guess what? Can your average engineer work with 25 gigabytes of point cloud data? No, the answer is no. So we're moving up the value chain here, right? Now listen, the guy with the faro, does he do this right here? No, he doesn't do that. He doesn't know how to turn on a cat on, right? Okay, let's go up one more step to the value chain and talk about, now here's where GIS comes in, BIM and GIS. Now let's say you're a company in California that owns 15 hospitals. Okay? And you keep hiring a guy that runs the faro because he's the cheapest. You're going to get a one-time value capture out of that data, right? What are you losing? So you're losing any value capture subsequent, right? Now, here's what I got to get surveyors to think about. Or let's say so for example, in Stockton, we have the University of Pacific. Huge property owner, all kinds of buildings, right? Okay. Now listen, if they hired a surveyor to oversee their scanning program, let's not even say that the surveyor did the scanning, but they hired a guy like you or me to come in and write the spec for what the scanning has to look like, and to lay out the control network, and to make sure that everything gets integrated. Over 10 or 20 years, what are they going to have? If you do it right, what are you going to have? You have a bunch of piecemeal data that doesn't fit together, that you can't do anything with? No, see? Now if I'm the facilities manager, and I'm managing $500 million worth of high-value commercial property in the middle of Stockton, see? Now this is starting to have some value to me, right? And I'll give you an example what really helped me understand this. One of the firms I work for, they did the bulk of the engineering work for University of the Pacific. And all kinds of surveys. And so the university was tearing down the old football stadium and they were putting up a new building. And so my engineer comes to me and he says, I need a price to like survey all the underground utilities and surface utilities, you know, in this 5-block radius, you know, this 5-block area, you know, within a certain buffer of this stadium. And so I asked the engineer, I said, Jeff, haven't we surveyed that before? He said, well, yeah, we probably have. And we've been surveying on this campus for 80 years, right? I said, well, why do we have to survey it again? What do you think he told me? What do you think his answer was?
So I can't find the old data.
Yeah, I don't know where it's at. I don't know how good it is. Is it on the same datum, right? And so I'm having a light bulb moment here, right? Like, this is insanity. It's insanity. This is insanity. And you know what that university did? Because the university doesn't want to pay for a good GIS. What did they pay my company to do?
Redo it.
We got paid to go back out and survey all those same utilities again. That is the definition of insanity. Listen, if I ran my house like that, I'd be foreclosed, right? But we've got people, project owners that do this. Now listen, not everybody understands this, right? But who's the professional that can make that work and bring the value in? Who is it? Is it the engineer? Is it the architect? Who has the ability to, listen, you're talking about infrastructure across 10 or 12 city blocks. Who's going to get all that to fit together? A land surveyor is going to do that, right? And so, man, GIS, where's it at on the value chain? See, way up here. And listen, I'm not trying to sell anybody snake oil, right? Like, this isn't snake oil. There's real money here for your client. You can really save your client money if you do this right. Listen, it's not just universities. It's everybody that maintains public infrastructure at any kind of scale. If they can implement this technology properly, it will save them money. Yeah, go ahead.
So, I mean, as you've been trying to educate your clients and get them to see the value of it, their budgets may not allow for it. I mean, right?
Yeah.
So they need to start thinking long term, I guess, and start planning. They need to start drinking the Kool-Aid, but they can't implement it necessarily right away because
it's a perfect question. It's a great question. It's a great observation. And so let me give you my response. I was just talking to a local city about this, like on Wednesday. We were talking about it, and the city guy was like, "Man, I know I need to do GIS, Landon. Like, I know it's important. Like, he's drank the Kool-Aid. I don't have to convince him, right? But he's like, he's overwhelmed." Like, think about it, you run a small city, like, where do you start, right? He's overwhelmed, and he's like, I need to do a GIS needs assessment, right? So he's like, man, I need to get somebody in here like you that can come in and look at the whole city and like come up with our 10-year plan for GIS, right? You know what I told him? I said, let's not do that. I said, it's great to have that comprehensive picture if you can, but like, you have no idea what you want or where you need to go. I said, let's start something super small. Just pick a small piece of your operation, and let's implement GIS for that. And listen, you're going to do that first 3 to 6 months, you're going to learn all kinds of things. As you go spend all this money coming up with this comprehensive GIS plan for the whole city, right? And the very first time you implement part of that plan, what are you going to realize? What are you going to do with the plan? Throw it out, right? So like, let's not do that. So here's my response, Mike, to you, and what I try and tell my clients is, look, you take this incrementally, right? You don't do this all at once. And so I'll give you a perfect example that I think surveyors will understand, and I've done this before successfully in practice. Let's say you're a county surveyor. Am I putting anybody to sleep yet? No? Only one or two people? All right. You guys are way too quiet. Let's say you're a county surveyor, okay? And do we have any county surveyors or city surveyors? No? Okay. Let's say you're a county surveyor. That means I can talk bad about it. Let's say you're a county surveyor, and I don't know, how many surveys do you think the county of Fresno gets on a monthly basis right now? Anybody know? Anybody want to guess? What do you think they get?
2 dozen.
2,000 a month?
2 dozen.
Oh, 2 dozen. So 24 surveys a month. We're talking record to survey and parcel maps and final maps. Okay, let's say 2 dozen. That's a good number. All right, now, let's think about how completely stupid this system is. This system is completely stupid. It's completely stupid. So let me explain. You're an AutoCAD. If you're like me, you have your surveys on state plane coordinates, because that's how we do everything, right? And I've tied out the monuments, and I put all kinds of time and energy into resolving this boundary, and I draw a beautiful map. And before I take it down to the county surveyor to submit the map, what do? I'm at my desk, looking at the drawing. What do? Before I can take it to the county surveyor, what do? I print it. Right? Like, let's go back to 1985 and print the map. Now, I print the physical map, and I carry it down to the county surveyor.
With a check.
With a check, a big check, right? And if the county surveyor is fairly modern, what might he do with that map? He might scan it. Yeah, he might scan it. If he's super advanced, he might have somebody do what with it?
Georeference.
Yeah, or Kogo it maybe. Like maybe it gets Kogoed and goes to the assessor, but most of the time, like 9 times out of 10 in California, when we bring the county surveyor a copy of our map, what does he do with it?
Folds it up, sticks it in a file.
Into a flat file. By the way, if you have flat files still, you're doing something wrong, right? Okay? So he puts it in his flat file. So 24 surveys a month on state plane coordinates, where are they going? Flat files. Now, and then if you want to copy the map or you want to find out where the map is, what do you have to do? You have to drive 2 hours to the flat files. Right? Like you can tell I get fired up about this, right? Because this is crazy. Now, let's think about how we can change that world for a minute. If you have the right kind of guy that knew a little tiny little bit about GIS, here's what he could do. Now, you're probably still going to have to get Mylars because that's the law. But let's just say he tells you, hey, when you submit your Mylars, could you please submit a DXF file with your map? Okay? Now listen, if a county surveyor asks me that, what am I going to tell him?
Yes, sir.
I'd say, hey, no problem. If that makes the, guess what? If that's going to shave a week off the review time for my map, no problem. I'll give it to you. I'll give you, maybe I don't give him the CAP file, but I give him some data, especially if it was a guy I worked with and I trusted, right? Okay, so now the county's got my CAD file. It's on state plane coordinates, and maybe, now listen, in California, if you tie out state plane coordinates, what's supposed to be on your map? What are you supposed to tell people on your map?
The control you use.
The control you use. So now he's got the control I used, and he's got the data, it's in state plane coordinates, and he's got it digital. Now, what can he do with that? What can he do with that? Now he's got it digital. What can he use it for?
Georeference.
All kinds of things. You can do all kinds of things with that. It can go to the tax assessor for the tax assessor map. It can go to the GIS department so they can correct the parcel line work. He can pick out the monuments off of the map. And so think about this now. You got a county surveyor who for the last 10 years, every time somebody's brought him a map, he's put the corners that are found on that map, found or set on the map, into a GIS database. Right? And he's done that for 10 years. Now what does he have? Like, how cool would it be as a surveyor to give a lat long to the GIS and see everything somebody's found in the last 10 years, right? Now, what does that cost? The system I just talked about, think about all the benefits that come from that. How much more would it cost? Almost nothing. In fact, if they would just let us get rid of the freaking paper, it would be cheaper. This is the definition of stupidity, right? Okay, now listen. Who are the guys in the room that understand how to fix this problem? So I'm going to rant a little bit. Is it the guy in the IT department? Is he going to fix that problem? The IT guy is not fixing that problem. You know what my most major headache with GIS, with every organization I work with, without exception, is I go in to talk to somebody that really is trying to get work done. about GIS, and do you know who they call into the room? They call the IT department in. Like all these organizations, the IT department is in charge of GIS. Now let me ask you a question. What does an IT guy know about GIS? Nothing. He didn't know anything about it. Yeah, he can't spell GIS. Now listen, I'm not saying that you don't have to have IT involved. Like you need servers and you need network cables and all the infrastructure has to work. But should that guy be making key decisions about how to implement GIS in your organization? Absolutely stinking not. Does the IT guy care about how hard it is for me to do map research? Does he care? The IT guy does not care. In fact, most of the time the IT guy doesn't want to talk about GIS because if you're trying to implement some kind of GIS, what is that going to make? What is that going to do for him?
It creates work for
It creates work. It complicates his systems. It's like, you don't want to talk about it, right? He's trying to keep his life simple. Yeah, and I'm not trying to, there's good IT guys out there. I'm not trying to stereotype, but so this is the problem that we have. Now listen, if you think about your typical city or county, how many opportunities are there like that, or utility company, to use GIS to more efficiently get the job done? Limitless opportunities. Let me give you an example. We got a job, a proposal to go dip 2,000 storm and sewer manholes in a downtown of a city. And good work. Like, I'm going to make good money. I'm not with the company anymore, but the company's going to make good money doing that work. It's all prevailing wage, so we're paying top, the citizens of the city of Modesto are paying top dollar to get those manholes dipped. Now, let me ask you a question. Is that the first time those manholes have been dipped? How many times do you think we've dipped those manholes downtown Modesto? Have they moved? Has the manhole moved? I don't know, maybe some sidings or some plate tectonic stuff, but and not only that, but on a lot of those modern systems now, when you design a subdivision, what do you put on your improvement plans? Why do we dip a manhole? What are we trying to get? An invert elevation on the pipe. What do you put on your improvement plans? The invert elevation of the pipe. So let's think about this. You bring your improvement plans into the agency with a big check, right, Mike? They take your big check, and what do they do with your paper improvement plans? They carry them over, they put them in a file, right? Okay, now, 5 years later, they're doing some analysis, trying to figure out, what to charge for sewer impact fees for the next 5,000 units, and they put out an RFP, and what do they want a surveyor to go do?
They want to go survey for the lowest price.
Yeah, as cheaply as it can, let's go and get what on all those pipes? This is the definition of insanity, is it not? Right? Okay, but so here's the point. I know I'm the president.
They have a budget.
They do have a budget. If they spend it, they lose it. I know. All right. Okay, so I gotta wrap up. What time is it? I get to preaching and then I run out of time.
Yeah,
I got 15 minutes. Okay. Here's the thing. If you don't remember anything else from today's talk, who are the guys and gals that can fix this problem I've been talking about? We can fix it. Like, we're the bridge between engineering and the measurement world. And listen, we are wasting taxpayer dollars. We are wasting utility ratepayer dollars. We are wasting money. Everybody's money is being wasted, right? We can fix this problem. We have the ability. Listen, is anybody else fixing it? No, nobody else is fixing it, right? My old boss, he didn't like GIS really. He's a super good guy, but it's GIS, but here's what he used to tell me, and it's true. He said, when the GIS world meets the engineering world, somebody realizes they should have called a surveyor. Isn't that true? That is so true, right? Okay, so why should it be us? Now, hold on, before I go to that slide, I want to clarify something. People, a lot of people say we should license GIS and we shouldn't let anybody but surveyors do GIS. And listen, you can tell from my story about the taxi medallion. Do I think that's the right move? That's not the right move, people. We're not listen, we're not stopping Uber, right? But I think there are, and not only that, but do I want to count repairing bush bunnies? Is that the kind of GIS I want to do? No, I don't want to count repairing bush bunnies. Let the bush bunny people count bush bunnies, right? Okay, but there are certain kinds of GIS that I think it just makes totally complete sense for us to be, not only should we be involved in it, but who should be running that GIS? Surveyor should be. So what kind of GIS am I talking about? Cadastral for sure. Anything cadastral related, right? And anything infrastructure related. Surveyors should be doing that, right? That's where the accuracy really matters. Okay, so let's talk about why. Why surveyors? Why should we be involved? Okay, so I've got some different things. First one, man, does anybody know about an analysis and adjustment of measure error better than a surveyor? Is there anybody that knows better than us? Nobody knows better than us. If you were here for Justin's talk before, you know that. Nobody knows better than us. Now here's why that's important. There's all kinds of data in the world. What makes GIS data special? What does it have? It has something that other data doesn't have. What does it have that makes it special? Why do we call it GIS and not, it has what? Thank you. Yes, it has spatial information. Now, the reason surveyors are so important in GIS is because what do you want to know about your spatial data?
How good it is.
Yeah, listen, if you don't know how good that data is, what can you do with it? Guess. That's all you can do. You make guesses, right? That's all you can do. So I would argue this is like super critical, right? Surveyors can tell you how good that data is. Okay, let's go down to the next one. Knowledge of coordinate reference systems. Let's just be real here, okay? Let's just be honest with ourselves. Does anybody besides surveyors really have a clue about how geodesy and coordinate reference systems and map projections and unit systems, does anybody else know how that works? Do your engineers know how that works? Like, engineers are smart people, right? Listen, does your average button pusher Esri ARC user really understand how map projections work? No, nobody knows this better than me do. I'm sorry, nobody does. Nobody knows this like surveyors do, right? And this is a key part of what you got to do to make GIS work. Okay, metadata management, GIS, people always talking about metadata. Let me tell you the problem with GIS. Who does metadata in GIS? The answer, no one. No one does metadata. That's why we have the problems we have, right? So I want you to think about metadata for a minute. Does everybody know what metadata is? Data about data, right? Okay, so like NSA, they can't listen to your phone call, right? That's the data. Okay, but they can know who you called and when you called and how many times you called. That's the metadata, right? Okay, so here's what I tell surveyors about metadata. Because listen, metadata isn't getting done. As a general rule, it's not getting done in GIS. This is another place where we add value. So I want you to think about a typical boundary survey, right? How much metadata do we collect? If you're a good boundary surveyor, how much metadata do you collect about your survey? All kinds of metadata, right? You know who was there, you know what tool they were using, you know if the wind was blowing and from what direction, you know who they talked to, right? You know all that. Not only that, but you kept all the raw data, like you know how good your stuff is, right? And you stake your license on it. So listen, do we have a handle on this right here? Absolutely. Like listen, nobody can do metadata better than surveyors, right? Like when it comes, like let's say you got a GIS and a manhole and a GIS, right? And you're looking at that manhole. Listen, nobody better than a surveyor to tell you how good that data is, right? If you do your job right, okay? All right, here's the last one. Now, I used to not think this was as important. People say, oh, surveyors, we need the control area, and whatever. But you know what? I've changed my mind on this. That's why it's in green. I realize how important it is now. And here's why this is so critical. You can't capture value in those data sets if you can't relate them to one another reliably on a good control coordinate system. Remember we talked about like the scanning the different floors of the hospital, right? Like this is it. This is where I have really come to appreciate just how important this is. Now I'm going to tell you, this is a crying shame. How many cities in California can you walk into? How many of those cities have a modern, up-to-date horizontal and vertical control system? Raise your hand if you think it's the majority. Anybody in here think it's the majority? There are some exceptions. There are some cities that do a good job with this, but especially mid-sized to small cities, their control network is 30 years old, if they have one. Listen, it took me 2 hours a couple weeks ago to find a benchmark near my project site in the city of Sacramento. This is the state capital, and I can't find a benchmark, right? And listen, like, I'm not a genius, but I'm not an idiot. Like, I should be able to find a benchmark, right? Okay? So listen, this is a problem, right? Now, who does this? Who's going to do this? Nobody else is going to do this. This is us. So listen, here's the conversations you got to start having with somebody. Listen, if you're a city or a county and you don't have people putting their survey work products that get submitted to you on a common coordinate system, you should be shocked. You should be shocked. You should be shocked. Okay? If you're a county and people are like designing roads and canals and like you're getting all those plans, right? And you're not putting that on a common coordinate system, you should be shocked. Period. Right? Now listen, this is what drives me so insanely crazy. 30 years ago, if you wanted to do a county-wide control network, how difficult was that? Or 40 years ago? Was that easy? That wasn't easy. Like, you had to, like, build me towers, right? So, like, that was a huge undertaking. It was insane, right? Okay, how hard is it today? It's almost effortless. And I'm gonna explain to you why I know that. I got a skeptic in the back. She doesn't think it's effortless. But let me tell you why. Okay, let me give you an example. My guys at my previous employer, we did all kinds of work GPS, a lot of RTK work. So here's what I told my boys: every time you take your base out, I want you to run the base in RTK and infill it, which means it collects static data while the head's running, right? And then every time the guys got back, I had a TBC project, a global TBC project, and I would dump that base data in there, and I would download the PBO data for all my local PBOs and cores, and I would post-process, like, while I'm waiting for, waiting for my AutoCAD to fire up, I got 2 monitors, right? I post-process on my other screen. And over the course of 3 or 4 years, I had a network that spanned the bulk of Central California, control network. NAVD88, NAT83, no more than a 10th error kicking around that network over several counties. In fact, the network was so good that I could watch the delta sync, and I could watch the points on the other side of the San Andreas Fault move over that 3 to 5 year period. Now, what did that basically cost me? Almost nothing. I mean, it took some labor, but listen, if you're a county surveyor or a city surveyor or a city public works director, is there any excuse to not have this done? It's so easy now to put stuff on a common coordinate system. Listen, if you're not that highly accurate, if you're not worried about super accuracy, like let's say you're doing the monument database I talked about, right? Like, you pull your RTN rover out of the truck and you put it on the monument, what do you got? State plane coordinate. Like, you may not know how good they are or what the basis is, but like, you're within a foot of something, some common reference frame, right? Listen, if I had a county surveyor come to me and say, hey, look, Landon, every map you do in my county from now on, it's got to be tied to a couple of control points, whatever, NGS points, or you got to time your course, it would get down on my knees and I would cry, right? Because even though that might be a little, it wouldn't be any extra work for me, but it might be a little bit extra work for some surveyors, right? In the end, am I going to benefit from that policy? Because what's going to happen now with everybody's map? Like, think about it, if we did that and I could pull the coordinates from that map and everybody's on a common reference frame, let's say within a foot, right? What happens to boundary search at that point in that county? Yeah, go ahead, Mike.
Well, sorry, you might want the answer to that question.
No, that's all right, go ahead. You have something different?
Well, Section 8771 of the PLS Act, the Monument Preservation, and it just dawned on me that civil engineers really tend to drive projects more so than surveyors. Within a municipality,
Yeah.
it's the city engineer
Yeah.
or the county engineer that's got
Yeah, that's
more
true.
got more clout.
Mm-hmm.
But this could be a way for them, because they're going to be. I mean, I know there's already complaints being filed with the board about city engineers and county
Yeah.
engineers losing monuments. This
Yeah.
would be a really easy way to sell the
Yeah.
monument preservation component of it.
Yeah, I don't want to give away all my secrets, but I'll tell you this, we're wrapping up. I got to wrap up. Mike's going to steal my secret now, but I'm going to tell him anyways. We got a local city that came to us. They said, man, we're really scared about this new monument preservation thing that got passed, and like people are freaking out, right? And they're like, how can you help us? And I said, well, you thought about a GIS? Well, no, not really. And so here's what we ended. We had some conversations with them. Here's what we ended up doing. We got paid to build a GIS for that city, a GIS layer of all the centerline monuments in the city. So we pulled every record map that had ever been filed in the city, and we found those points. We plotted them on the GIS parcel layer, and we signed an attribute. And it's not survey grade, right? But it's, now listen, anytime there's a project in that city, what do those guys do now?
They go look for the monuments.
Yeah, and they tell the permit holder, look, sorry, you got to call Surveyor, you can't get your permit. We know there's monuments in your project area, right? And they're doing that for city projects too. Now, that the other piece of that is now every year before they go out and they do their city pavement projects, they're hiring a surveyor. So we did it last year. It may not be us this year, maybe somebody different, but every year they're hiring a survey out to come out and do post and pre-construction records of survey on those paving projects, which is what they're supposed to do, right? So last year, I surveyed almost 1,000 monuments that were part of their paving project, their projects for the year, right? And now what's going to happen with all those survey grade coordinates that are on a common coordinate system? What's going to happen to them now? I'll go back into that GIS database. So guess what? Over the next 20 years, what's going to happen to the quality of the centerline monument coordinates in that database? Right? It's like there's a city that's got it, they're moving ahead, they're getting it figured out. So you're right, there are some people that get it. I don't think that would have happened if they hadn't passed the modifications to 8771. Yeah. So anyways, all right, so to my last slide, what type of surveyor do we need? Got to be comfortable with technology. I'm trying to get people to broaden their perspective a little bit, right? Think about the bigger picture. How do you move up the value chain, right? Where do we save money? What's the problem we're trying to solve? What's the problem your client's trying to solve? Focus on value. How do we add value, right? You're not adding value as a rough grade contractor anymore. Rough grade staker, so you got to think about that. And what does this really take? It really takes surveyors that are willing to lead. Like there's an education of the public and an education of local officials, right? And like, who has the answers to these problems? We do. What does that require? If you're the only guy in the room that has an answer to the problem, what do you have to do?
Give the answer.
You have to open your mouth and give the answer to the problem, right? That takes a willingness to lead. And guess what? You know, we're not, like, if we were super handsome and gregarious and outgoing, we'd be politicians. We're not. We're surveyors, right? So that pushes us outside of our comfort zone a little bit, right? But it's important. And for the private guys in the room, I would say this. You know, I'll conclude with this. Not only is this smart, it's a smarter way to work, and it's a smarter, you know, it benefits our communities, like we care about the communities we live in. But the title of the presentation is the business case for greater surveyor involvement. So what do I want my private sector guys to remember when they leave the room today about this technology? What can I help you do? You can make real money doing this. I mean, I probably, the last 2 years, I'd say I've easily done $200,000 worth of GIS work that my firm wouldn't have captured if we hadn't had the ability to work with this technology. So, yeah, go ahead.
Share a couple of comments. One thing that I have found myself doing is kind of adding on little things to what the client asks for, and kind of thinking beyond what they ask for and giving them something I think they might like.
Yep.
And Google Earth is a great way to share information in a way that is very helpful for them, and it doesn't cost them anything to get on board with it. Sending a shapefile at first is kind of daunting. You have to go find a new program or how to use it, and so I hate to use this analogy, but the drug dealer approach really does work in this sense. Offer them a KML file for free. They never ask for it. You never say you're going to give it. Just throw it out there. Then the next time they say, "Oh, that was neat. Can you do that again?" Sure, here it is. Sooner or later, that starts showing up on your proposal as an added fee. And now they're willing to pay for it because they like it. They want it. They crave it.
Scott has an excellent comment. Yeah, the very first paid GIS job I did came after we donated an intern, my time and the time of an intern, engineering intern one summer, to build a GIS for a little sanitation district. We did it for free, didn't charge them anything. And that following fall, we got a $30,000 contract to go survey the manhole rims on the trunk lines and to integrate that into the GIS we built them and to do a wall map. So Scott's right. You know, sometimes you got to risk a little bit to get your client started, and then there's you know, the nice thing about GIS, you do a boundary survey once. The nice thing about GIS, well, I'm gonna have to edit this out of the tape. The nice thing about GIS is it's the gift that keeps on giving, right? You know, there's long-term revenue potential there, regular revenue potential. So, all right, go to lunch. Thank you for your time, but go.